Today we are doing an activity called Atoms in Motion, a hot and cold experiment. This experiment is intended for third graders and uses the California Science Standard 1C and H, which talk about heat and cold and atoms. What you'll need for this experiment are clear plastic cups, food coloring, and a timer. If you don't have that, you can use just a classroom clock. And the students will need to get into either partners or small groups of 3 or 4, depending on your class size. And make sure you discuss with them what atoms are, the different states of matter, solid, liquid, and gas, and the way atoms move in those different states of matter. So first, what you'll need is hot and cold water. It's best if you prepare this ahead of time, so when the students come in, the desks are all ready to go. I just used refrigerated water and just warm water from the tap. And everyone needs just one food coloring dropper per group. And what you're going to do is let them drop 2 or 3 drops into each cup as quickly together as they can. And then they can start the timer, and they're going to record their results after 1 minute and 5 minutes, and then also take note of how long it takes to fully mix in the hot water and in the cold water. So we'll start off by dropping our 3 drops, 1, 2, 3, 1, 2, 3, and starting my timer. And you want to make sure they're really careful not to bump the table, because that'll cause the water to move and mix the food coloring on its own. But in the activity sheet, they can draw their results in the box for 1 minute and 5 minutes, but also to pay attention. If you come a little closer, you can see already how it's mixing in the hot water versus the cold water. So as we approach 1 minute, you'll see, well, I don't know how well you can see from the video, but if you look closely at both, you can see we're at 49 seconds and the hot water is pretty stirred up. You can still see groups of the food coloring, but if you look at the cold, and I'll show some pictures, you can see that the food coloring has either stayed on the top or at the very bottom, and there's some clear water still left in the middle. I don't know how well you can see from far. Now we're at 1:12, so they can start drawing their results for 1 minute in their table. And also, if you hold up some white paper behind, it'll let you see the food coloring a little bit better, so you can let the kids do that as well. And then we'll pause and come back at 5 minutes. We're now at 3 minutes and 22 seconds, and you can see in the hot water, it is, I would say, just about completely mixed. The water is the same color blue throughout. There is some food coloring pooling at the bottom, but I would say your students can record whatever time they get. That for me, it was 3 minutes and 22 seconds when my hot water was completely mixed up. And my cold water is still a little more mixed. The food coloring is falling from the top, but it's not nearly as mixed as the hot water. All right, and we're just about at 5 minutes, and you can still see differences in the two cups of water, so you can now have your students record at their 5-minute mark. And depending on how much time you have, you can leave the cold water cups out, and so they can get a time measurement of how long it actually takes for the food coloring to mix in the cold water. And here we are at 5 minutes. So for me, my cold water is looking mixed, but you can still see the food coloring waving through it. My hot water was mixed at 3 minutes and 22 seconds, and it's just getting darker and darker because there's still some food coloring at the bottom. But like I said, if you have the time, you can let them leave the cold water at their desk so they can see how long it actually takes for it to completely mix up. We'll see. I'll leave my timer on and see how long that takes me. We're now at 10 minutes and 7 seconds, and my cold water is almost completely mixed. It's still not quite as uniform as my hot water, but it's slowly getting there. But to wrap up this experiment, your third graders should now have a little bit better of an understanding of how atoms in hotter temperatures are moving around faster than atoms in colder temperatures, or even further than that in a frozen or a solid, that they don't yet have any space to move around but are vibrating, and in liquid and gas and warmer temperatures they have enough room to move around as they please. And good luck conducting this experiment with your class.